care system you can make smart healthcare means from your native place, from any one place you can do the proper treatment. Those the patient who are staying very far, like in Mumbai, Tata Memorial Hospital, one patient is there. There is diagnostic system is there, uh, like when you are measuring pulse rate or temperature, like cardiac related issue. So various instrument, medical instrument. In each instrument, so many sensor is there, different sensor is there for measuring different parameters. So system is there. Patient they will monitor through that device. They will diagnose the parameters, and that data through internet will collect where you are sitting, like in your cabin. Okay, you can find that data level, what is the heartbeat level, what is the like all parameters, even kidney related, blood related, every data you can find here. And based on that data through internet, what you can do, you can give the suggestion to the healthcare staff, those who are there. Based on your instruction, they will give medicine. And other way, you can do the treatment actually automatically, even you are not actually checking the patient data, and you can, like what, based on the diagnosed actually parameters, like this is a cancer disease, so for cancer this parameter actually measured, and based on that data you can write the code, you can write the program using machine learning or artificial intelligence. Okay, then what you can do, based on that program, again from that program, as a actuator, as a output, nearby that hospital, in hospital, their instruction will come, and the healthcare staff, like this, for this temperature this medicine should give, for this parameter this should be give, here they will give properly. So see, without doctor means you already written, doctor will not write program based on requirement, based on doctor suggestion. You can design the IoT based system, and getting the actually knowledge and information from doctor and system or that parameters, you can write the code, you can write the program, and based on that the doctor can actually treatment possible, like that. So smart. Now I'm coming to like how you can design a smart home. Inside home, AC is there, television is there, getting like door lock is there, everything is there. But suppose no one in the right now in your home, you are starting journey to reach your home, so that home should cool, like so from you can give instruction, okay, so that your AC will on before 10 minutes or 20 minutes, so that your room becomes cool. So from a car only you can give instruction, your room becomes like cool. On TV without reaching also, you can open your door just when you reach the gate, near gate. Okay, even water, suppose parking is there, park like a plant also is there nearby your house, so plantation also you can do properly, like moisture level becomes less, so you can measure, and you can give the like command, so that pump will automatically start, and that watering you can do, like that. So this everything, so whatever in your home, okay, there, that everything you can so that smart home also you can design. Similarly, transportation related, transportation, uh, you have one industry, you have a one actually business. In that one, 100 buses or 100 truck you have, and through that truck, what you are doing, you are actually supplying the medicine, or suppose like a vegetable or like fruits, entire the country. So you have to monitor the properly where it is at what time it should reach that place. Okay, and if any problems, how you can find. So properly what you do, just keep like a alcohol sensor in front of doctor driver in your truck. Driver if drunk with drunk, then you, according to your program, vehicles should automatically stop. Okay, like that, so accident you can reduce. Suppose any problem there, you can send the stop, you can repair, you can, like that. Transportation part, transportation also make smart, so that your business will grow, you can earn huge money, like that. So in transportation section nowadays, IoT based actually, uh, so that is that's why emerging application in transportation. Similarly, in a smart infrastructure also, in, like suppose you are talking like smart city. So how you can build a smart city? So a smart city means like in one city, what are the requirement, so that we can say it is a smart. Like in short, not I am going deeply, but like just like smart parking should be in a city. Smart traffic light, traffic light uh, controller should be there. Proper, actually in most of the shopping mall, actually proper management should be there. Okay, so in railway stations, huge crowd, how you can maintain. In bus stand, how you can maintain huge crowd, getting like that things. Everything should be actually surrounding of any city, how you can control the like temperature also. So like pollutions, you can measure and you can control also. So in this way, smart city you can, so like in a smart infrastructure, even smart building you can design using like in one building like a lift. So lift also, right, embedded system or IoT based, you can design. So actually we are surrounded with internet of things. Without internet of things nowadays, actually nothing possible. That's then I'm talking security and surveillance. Security, why it is very important nowadays, basically like Amazon, PTM. So that's like a financial activity those who are doing. Okay, so if security is not there, okay, even like security means you can say in different way also you can see different in defense sector, the data whatever actually they are sharing, that should be very secure. Okay, so that way also you can see, but here security and surveillance should be actually very strong. So in that way also IoT based nowadays work is going on. Then in retail field also, retail field nowadays, you know, like woodland shop is there in entire country. So actually owner is sitting like Delhi, and they are controlling entire business from Delhi only. Why and how? Like see in Chennai, so many woodland shop is there. So in most of the shop, like actually inside, if any people's coming, sensor is there. They are sensing, measuring how many people enter inside. What are the actually so how many purchase or selling happen. So this everything you can control, you can monitor from your Delhi or in one place. So in retail also, retail section, even online purchasing, online selling, that is nowadays like Amazon's doing that things also you can do. So retail things also nowadays in through internet we can do. In industry, I told actually like in any plant. So if automated plant means what we are doing, based on requirement we are writing program and automatically we are controlling the plant. Okay, so there also actually IoT based that plant nowadays automated, then your productions will increase, demand will increase, like that. So entire business setup is depends on like this IoT. Then this all actually things in this three step it is working like so first things from sensor data should connect. So data connection or data collections. Okay, so sensor from sensor will data will connect. So data sensing from sensor, Then communication, that data should communicate. So communication part is the other part of IoT. Okay, then communication means sending the data to proper place or in cloud. Okay, then next is the data analytics. So if you are sending the data or communicating to the cloud, so in cloud what we are doing, actually data analytic we are doing. So data is a big, so big data analytics or AI or machine learning based. So we will do that. Then data value analysis to action. So that things next finally we will come to the human value. Okay, so these are the steps to complete this IoT design. Okay, in simple way, same things whatever I discuss here, how it is working. So see in lab here, in top left side, data storage part is, that is the cloud or edge computing or fog computing. Okay, or simply memory also. In down internet, internet, that is networking part, and top remote control and router gateway, and finally right side see IoT device. So what is the IoT device means? From here data generation and collecting that data through gateway will send to the internet. Through internet that data will be in cloud. Okay, or same data you can control through remote control. So here in right side topmost written how the internet of things work. So first storage device will work, will collect the data. For future we can store the data or analyze the data, or we are doing analytic. Okay, so that is in cloud. Connection of remote device such as a smartphone, basically it will control the IoT getting. Then internet, basically it provide the connectivity platform or networking. Okay, a router and gateway will allow device to connect via Wi-Fi, and thousands or billions number of device will connect to the internet. So in this way, here we will show one video, but already time very less. So in short, we'll go ahead. This actually this is the IoT product development process here. So here hardware first, then how you can design complete. So circuit design, then PCB design and fabrication. That is complete electronics part. Okay, so PCB and fabrication. Then we are coming to the assembly part, board and hardware and interface testing will test. Then applications part will come, application testing part. So in this step, we will complete the IoT product development process. Okay. These are also real-time use case. Already I discussed this, one truck is there. So how here different sensor even will, if you connect one sensor in wheel, so speed also you can measure. About health of tire also you can measure. About actually driver also you can measure. So in a near in front of driver, sensor will connect. Backside, every sensor will connect to the Raspberry Pi through the networking. Okay, Raspberry Pi is nothing. It is a small computer where we will do the processing part, and this data will send to the through internet, in cloud server. So in cloud, data will store, and we can we will do the analytics either using machine learning or AI. Then admin dashboard. That is a, so this is the complete one real-time user case. Uh, Hospital-based one already discussed. Okay, then other emerging use scenario in a smart grid and remote patients monitoring. I'll discuss already discussed very well. Then cloud computing. So cloud computing and edge computing and fog computing, that is based on application. So once again, I'm telling IoT is nothing. It is applications specific subject. Application is specific. So it is not a particular one subject. So for to understand this complete IoT, you should learn. You should know the basics about the electronics, most of the topic, about the electrical field, even mechanicals also. In computer science, data analysis you should know, and even machine learning, AI. These all things are required to understand complete IoT. Then you can design a real-time based IoT product. Okay. So IoT based, actually nowadays, actually most of the industry or actually in most of the area, IoT based actually startup or even under me so many students written actually patent work. They have designed hardware product also, like smart parking, smart home, smart aggregation system. I'll show one video. Okay. So here cloud computing. So this part only totally related to computer science student, but to understand complete IoT, cloud computing is very important. Edge computing is very important. So cloud computing is a infrastructure and software system that allow for access to share network of storage, server, and application of the over the internet. So that is the cloud. Okay, and with cloud computing, user can access database resource via internet from anywhere for long as the need without worrying about the maintenance and management of actual sensor like this. So it is a server which is accessed over the internet present at remote location. So this is the server. Okay, storage managing, here data can also store. So storage managing accessing of data and program on remote sensor that are hosted over internet instead of computer hard disk. Getting? So there is no hard where actually where we can store the data. It is a cloud. Okay, it is a server which is accessed over the internet present at remote location. Computing service over the internet, software storage, server, database, networking. These are actually in cloud computing. Okay. Some limitations of cloud computing like at latency, bandwidth, availability, and energy. So these are the main limitations of uh, cloud computing. Latency means in the traditional cloud computing model, applications send data to the data center and obtain the response which increase the system latency. For example, high speed actuator, okay, driving vehicles requires millions milliseconds of the response time. Getting? Uh, then bandwidth also limiting limitations. Transmitting large amount of the data generated by billions of the device to the cloud in real time manner will be great actually challenges. Then availability, so as more and more internet service are deployed on the cloud, and availability of the service has become a integral part of the daily life. So therefore it is a big challenge for cloud service providing to keep this 24-hour promise like that. So this is the then energy also one limitations. Here cloud is a various type like a public cloud, private cloud, hybrid cloud also, and community cloud. So based on actually application, different cloud is there, like see public access. So public cloud can access publicly. Then a private cloud, so it is a privately on. Okay, so service access well within the organization. So that is a private cloud. Then hybrid cloud, both types, public and private. Okay, then a community cloud actually service access by group of organization. Okay, so these are the types of cloud. Here IBM have it's on a public cloud, Amazon also, VMware, and Google also, like that. Some advantage and limitations of public cloud also there, like public cloud is on at lower cost than the private and hybrid cloud. Public cloud is maintained by the cloud service provider. So public cloud is easier to integrate, hence it is offer a better flexibility approach to the consumer. Now actually time is very less, so just I'll come to the one project how you can design. So one I'll show here so many resource actually open source. We'll see, then we'll complete actually say these are the yeah. So here some open source software is there where you can do IoT based project like Thinkercad, ThinkSpeak, Node-RED, ThinkSboard, and Things.geo, like that. These are the open source where we can do. So to design this, some like gas sensor left side is there, right side Arduino board, Arduino Uno board is there. So you have to drag and drop, and you have to connect the circuit, and you can check. You have to write the code. I'll show you one. So just these are the code. Okay. here actually how many pins, which pin you are connecting. So these things we have to define here. Okay, like see, this is a one a pot in that soil is there. So to save this actually plant, soil moisture should be monitored. So soil moisture is kept in soil, and based on this, actually what you can do, motor you can switch on or off so that you can do the proper watering of this plant. Okay, so these are the components required to design this IoT project. This is the Arduino board, one soil, some connecting wire, soil sensor. Okay, and similarly, I'm coming to the wait 1 minute. I'll show you exact. These are the project I have designed. Just I'm showing. Wait. It is not. Sorry. Okay, I'm showing just one video. Then I see. Okay. It is not opening link. I think maybe. Okay, now I'm just showing one video. Through that you can understand. Okay, so see, is it so in short, actually how you can design how it is so so you can see this video and you can find how actually healthcare by using IoT based concept you can design and you can make a smart healthcare system. Okay. हाँ सर क्या कर क्लोज करो कि ओके 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 so like this smart actually healthcare you can make using IoT based. So actually these are the project our student design. Okay, using Thinkercad. Even hardware you can design. So here actually Arduino board required, some breadboard also you can use for proper connections. And here actually how you can design like see one project our student design. This is a real time use case in Thinkercad. Okay, so there's so many project. Is it visible? Just anyone reply, is it visible or not? Getting anyone? Hello?
Yes, yes, sir.
Anyone getting?
Yes, sir.
Okay. So by using Thinkercad, you can actually design, just I'm showing here, just click Thinkercad. Then you can type, see here, Thinkercad. See, Thinkercad. Okay. Just I'm showing you. Okay. just how you can design a IoT based project using Thinkercad. You can see here, but time is very less. So wait. My screen is visible.
So,
Is it visible?
yes, sir. Yes, sir. Kindly, sir, conclude within 1 minute, sir, because
Okay.
next session is going to be starting. Please conclude within 1 minute.
No one is replying. Then how I can find you are getting or not? Hello,
Yes, sir.
hello
Next
everyone.
session is going to be. So, kindly conclude your presentations.
Okay, then so in this way, actually you can complete. Now I'm
So,
coming to the other
thank
point.
you.
I have 5 minutes, so just each computing and like say, what is the is ML. Okay, so I discussed about the actually cloud computing. Then we are coming to the uh, uh, is
The last 1 minute,
computing or
sir.
is
Kindly
ML. Okay,
conclude, sir.
so here this advantage of is ML IoT also I discussed. Then we'll see private cloud computing and public cloud computing. Then I'm coming to the edge computing. What is the edge computing? Actually, we can understand this one by using one example. Okay, so like see, suppose you are going to design a smart parking. So what nearby smart parking sensor is there. Suddenly you can sense the data, process the data, and as a output you can get there. So no need to send that data to the cloud. Getting why? Because quickly, that is a real time application. So why will send to the data to the cloud? Not required. So nearby the edge device, if your computation is doing, that is called edge computing. Okay, so edge computing is a distributed computing. Okay, for the different application. Okay, so computing model that brings computation and data storage closer to the edge of the network. I told you. Okay, it is a closer to the edge of the network. That's why its name is edge computing. Okay, near the source of the data generation. Near the source of the data generation means who is generating the data? That is sensor. Okay, so see in down figure, down part that is different IoT device is there, and nearby that is there. So in edge computation part happening here only. So that is very fast. Okay, so in edge computing, data processing and storage occurs at or near the device or sensor level, not in cloud level, rather than the relying solely on the centralized cloud server. Getting not in cloud. So this approach
Yes.
enable faster
Excuse
processing,
me,
real-time
sir.
analytics, reduce latency,
Excuse me,
and
sir.
localized decision
Hello.
making. So that is a very good thing is computing.
Hello,
Okay.
am I audible, sir?
Now,
Excuse me.
actually, here in edge computation and cloud computation, you can find here. See, so as I told, cloud computation is a cloud-based approach. The video footage from all the camera is transmitted to centralized cloud for the processing. Okay. Hello. Okay. Okay. Take it. Okay, so time I think already taken extra. Sorry for a network issue. Now other professor, other session is going. Sir is waiting. So if required, I'll share this PPT materials to participant. And if you have any query, then I'll share my mail ID and my number. You can directly contact to me. No issue anytimes. Okay. Thank you, sir.
Okay, thank you so much, sir. Your insightful discussion covered the extensive applications of IoT technology, demonstrating its transformative impact across various industries. You detailed how IoT facilitates the interconnection of devices, systems, and services beyond traditional machine-to-machine communication, extending to a broad array of domains, including healthcare, agriculture, manufacturing, and smart cities. During your lecture, you highlighted specific examples such as smart home systems that enhance energy efficiency and personalized healthcare solutions that monitor patients' health in real time. So thank you, sir. Right now, our resource persons have joined. Munish, sir, are you online? Hello.
Hello.
Yeah. Yes, sir. Yes, sir. Thank you, sir. Good evening, sir. Welcome, sir. And okay, so I'm going to introduce about our resource person. Professor Munish Trivedi has more than 20 years of experience in the field of computer science and engineering and has worked in prestigious institutions. He has more than 10 years experience in various administrative responsibilities, such as Dean Academics, Head of the Department, TQ Coordinator, PG Coordinator, ADC Sale Coordinator, currently working as Professor Computer Science, PSSCIV Bhopal, a constituent unit of NCERT under Ministry of Education, Government of India. Prior to this, he worked as an associate professor at NIT Agartala, Tripura, India, an associate professor, HODIT, REC Azamgarh, UP, State Government Institution of UP, with the additional responsibility of Dean Academies of the Institute and Associate Dean UG programs, Dr. AKTU Lucknow State Technical University. He was also director in charge at REC Azamgarh. He had successfully filed 65 patents, 52 national and 13 international patents, out of which 35 patents were granted. He has published 12 textbooks and 153 research papers in different international journals and proceedings of record. He successfully supervised 14 PhD students and received numerous awards. Welcome, sir, and thank you, sir, for accepting our invitation. So, hand it over to you, sir, please.
Thank you, Dr. Dilip, for the wonderful introduction and inviting to deliver the address. So, as I have seen, this short-term course is basically for the UG, PG, and research students. So, I try to kept the basic level only. Sweta, please mute yourself. So today we will discuss some of the techniques of the machine learning that we are using for the disease predictions, and what are the research area, future research area challenges of the medical imaging that can be done with the help of machine learning. So PPT is visible. Hello.
Sir. Yes, sir, visible, moving, sir. Okay, sir.
It's moving.
Nice. Yes, sir. Yes, sir. Everything is fine, sir.
So today we will discuss some of the basic concept of the data science, machine learning, and how they are useful in the diagnosis of disease at an early stage. So as we know that the data science is closely related in the healthcare domains. So as we are saying that whenever we are talking about the healthcare, so it basically involves the improvement of medical services, how we can improve the medical services, and how we can improve the medical services. Somehow it is related that early identification of the disease. So we are incorporating the IT concept, or we can say data science, machine learning. These all are the IT concepts. So we are basically including these concepts so that we can early identify the disease. If we are able to identify the disease at an early stage, then what will happen? The medical practitioner, the doctors, they can start the treatment at early stage. And when they start the treatment at early stage, then the chances of recovery is also very high, as well as this is also reduce the cost of treatment. So that's why the data science and machine learning is playing a vital role in the improvement of medical services. Whenever we are talking about the healthcare data, so normally the healthcare data is typically falls into the three categories. First one is the clinical data, second one is the omics data, and third one is the sensor data. Whenever we are talking about the clinical data, so clinical data is just the electronic health record. Like we are having the CT scan report, we are having the X-ray report, we are having the ultrasound record. So if we are having the electronic version of these all health records, so that is termed as the clinical data. Omics data is somehow we can say the high dimensional data, and that is basically comprising of genomes, transcriptome, and protein. These are you can generally say the DNA and RNA related data of any particular patient. So here we have to take the previous record means their forefathers record also, so that we can match the DNA and RNA reports. Third one is the sensor data. Sensor data is basically collected from various wearable and wireless sensor devices. So when we see that we are having the three types of data, so to handle the large amount of data, it is very difficult. We cannot handle such data manually. So that's why the concept of machine learning, data science, and other IT concept is required, so that we can easily collect the data, we can easily organize the data, and we can easily analyze the data in most efficient way. So whenever everyone has heard about the big data. So what is big data? So whenever we are talking about the medical image, or whenever we are talking about the healthcare sector, so here basically we can say the amount of data is very large, because we are having the clinical data, omics data, sensor data, all types of data we are dealing with. So whenever we have to identify any particular disease, so we have the large set of data. So whenever we are having the large set of data, it is not practically possible that such large and complex data we can do the manipulation, identification, and recognition with manually. So that's why we are using the machine learning algorithms and data science techniques to identify the disease at the early stage. So how the data science uses in the healthcare. So whenever we are talking about the data science use, we can say if we want to do the medical image analysis, that is possible with the data science techniques. And like we can also provide the virtual assistant to the patient whenever is required with the help of data science. And we can also do the data management and data governance, and we can predict the disease stage. And even whenever we have identification of the disease is done at the early stage, we can prevent the disease sometimes. And how the data science and machine learning is playing a key role in data science. So as we have discussed, that these both techniques are basically used for the identification of disease at the early stage. Whenever we are identifying the disease at early stage, so somehow we can like uh, treat at early stage, and even we can say we can prevent the disease. So as we know that healthcare sector is having the massive amount of data, large amount of data. So it is not possible to find out the pattern, to find out the trend, to find out the reason, and to identify the disease in so massive amount of data. So that's why the machine learning techniques, they with the help of machine learning algorithms, we can identify the pattern, we can identify the disease at an early stage, and accordingly, the medical practitioner can decide the next course of action. So, how this machine learning algorithms is working? So, how the machine learning algorithms can help in the diagnosis. So, as we have seen that hospitals have started machine learning techniques to use for the identification of what exactly. Hello, do you want to say something?
Hello, sir. Your slides on the first slides.
Slide is not moving.
Moving. Yes, sir. Yes.
Now it is moving.
Yeah.
Hello.
Now it's moving, sir. Yes, yes.
So we are
Thank you,
talking
sir.
about how the machine learning can help in the early identification of the disease. So as we know, like we are having the CT scan reports, we are having the MRI reports, we are having the ultrasound report. So if like by seeing those particular reports, if we are having thousand persons report, lakhs of persons report, 10 lakhs persons of report, it is not practically possible that manually we can identify if such pattern is exist in CT scan report or MRI report, then that particular disease is happening. But if we are having that data, and if we apply machine learning algorithms, then why with the help of that input and output, we can easily identify like what are the symptoms and what particular disease is going to be starting that particular patient. So in this way, we can say the machine learning is helping in the identification of the disease. So how the machine learning is working, as we all know, we are from the computer science background, that machine learning algorithm is typically falls in the three categories: supervised learning, unsupervised learning, and semi-supervised learning. So whenever we are talking about the supervised learning, means we know the input, we know the output. With the help of input and the output, we are training, we are learning to find out the patterns. And the techniques that we are used in the supervised learning is the classification and regression. So classification and regression are the two techniques that are basically used for the supervised learning. And the major objective of supervised learning is to develop model based on both input and output data. Second one is the unsupervised learning. So here we do not have the output. So with the help of input only, and by using the techniques of clustering, we have to group the data into different cluster and interpret data based only on the input data, because here we only know the input data. So we have to cluster, we have to group the input data into different clusters and apply the algorithms and find out the hidden patterns and structure based on that particular input data. Semi-supervised learning is, you can say, the mixture of both the approaches, supervised and unsupervised. Another term that is related with this is deep learning. So whenever we are having like a small amount of data, or we can say, then we can use the machine learning. If we are having large amount of data, so sometimes the machine learning algorithms do not work properly. So in that particular case, we are using the concept of deep learning. Somehow deep learning is the subset of machine learning only, but it is used for the large amount of data. So the most complex form of machine learning that involved in this particular scenario is the deep learning neural network models, you can say, and that basically is applied when we are having a large amount of data. So the common application of deep learning in healthcare is basically identification, or you can say the recognition of cancerous lesions in the radiology images. As we have told that this particular methodology, deep learning, is the subset of machine learning only, but it typically deals when the size of data is very large. So normally whenever we are talking about the cancer patients data, then you can say in order to find out the lessons, in order to find out the growth of the cancers, we have to match the large amount of data. So that's why typically the deep learning algorithms are most suitable in the identification of cancerous cell or cancerous lesions. So what is unique about ML in healthcare? We can say, as we know, that if we are able to identify the disease at early stage, then we can prevent the disease, as we have discussed. If we are able to identify the disease at early stage, then we can take the support from the healthcare professionals, and we can recover fast. Even we can save the money. So basically, the machine learning algorithms is helping in the life or death decisions. So that's why we can say this is the like one of the most important features. Another, like whenever we are doing identification of disease manually, so sometimes what happening, sometimes that particular doctor, the medical professional, they are able to identify disease accurately. Sometimes by seeing their own eyes, they are not like able to identify the disease properly. So, but whenever we are doing these things automatically with the help of ML algorithm, so we are quite fair, and we can say the algorithms are normally giving the accurate result in comparison to the normal human beings. So here I will discuss like one of the example. One of my PhD scholar is working in this particular domain, like classification of glioma grades into high grade and low grade in MR images using machine learning. So how, with the help of machine learning algorithm, we can classify the glioma into high grade and low grade. So what is glioma? First, we have to know about the glioma. So whenever we are talking about the medical imaging, and in medical imaging, one type of disease is brain tumor. So whenever we are talking about the brain tumor, so we can say that brain tumors occurs around uh, 2,50,000 pupils in a year globally. Means every year 2,50,000 persons are suffering from the brain tumor around the world. Okay, but only less than 2% is cancerous. So we have to identify that out of 250, how many are the cancerous, because we have to bother about the cancerous only. Those normally were having brain tumors, but they can be easily cured. So, like whenever we are talking about the brain tumors, so the major problem is they vary in the shape, size, appearance, color, location, orientation, and other features. So the major drawback of manual detection in brain tumors is time consuming and prone to human error. So we cannot like say that by manual detection we can easily identify the shape, size, and whether it is cancerous or not. So, like whenever we are talking about the brain tumors, it is generally fall into the two categories. First one is the benign category, and second one is the malignant category. Whenever we are talking about the benign category, so benign category brain tumor is non-cancerous. So we have to not bother about if the brain tumor is of benign category. Another aspect related to the benign category is grow slowly. They do not spread into the other tissues so fast. Their growth rate is very slow, as well as they have the clear borders. Means whenever they are growing, their borders are clear. We can easily identify their borders. But whenever we are talking about the malignant brain tumor, so malignant brain tumor is the cancerous, as well as their growth rate is very high, and they do not have the clear cut borders also. So if the growth rate is very high and even the border identification is difficult, they are cancerous. So we have to bother about the malignant brain tumors because they are cancerous also, their growth rate is high and their border is not possible to identify. So glioma is the most common malignant brain tumor. So glioma is what? Glioma is nothing but it is the type of malignant brain tumors. So we have to like identify because it is cancerous. It is like the growth rate is very high and it is having the distorted border. So we have to bother about this malignant brain tumor, and glioma is one of them. So when the levels of tumor dimensions. So first we have to detect the tumor, then we have to segment the tumor, then we have to classify the tumors. These are the three levels. First level we have to identify, then we have to segment, then we have to classify. So for the tumor detection, like if we are having the data size is less, then for the tumor detection we can use the traditional machine learning algorithms. For examples, SVM, PNN, BPNN, and CCANN. These are the traditional machine learning algorithms that are used for the tumor detection. But if the size of data is large, we can go for the CNN and DNN, means deep learning techniques. Similarly, if the size of data is less, then for tumor segmentation also we can prefer the traditional machine learning algorithms, SVM, PCNN, FCM, and BPM. And if the size of data is large, then we can go for the deep learning techniques and the deep learning algorithms. Same approach is for the tumor classification. If the size of data is less, then we can use the traditional machine learning algorithms. Otherwise, we can go for the deep learning algorithms. So the key difference between machine learning and deep learning. So whenever we are talking about the definition of both, so machine learning is subfield of AI, and that if we are talking about deep learning is also the subfield of AI, but it is subset of ML, means it is inside the ML only. Whenever we are talking about the data feeding, so machine learning will give the accurate output whenever we are feeding the structured data only. But in the deep learning, we can give the unstructured data also. We can give the raw inputs also. Whenever we are talking about the volume of data, so machine learning models basically deals having thousands of data rows, means we are having the size of data rows limited into the thousand only. So if the data size is less, means in thousands only, then we can go for the machine learning algorithm. But if the thousand of data, if the data size is large, then we can go for the deep learning algorithms. Even if we are having the millions of data rows, then also the deep learning algorithms perform very well. Training time, so machine learning, as we have seen that it is having the less amount of data, so training time is also very less in the machine learning, while the training time in deep learning is very high, because here we are having the large amount of data, massive amount of data. Whenever we are talking about the human involvement, so machine learning models are easy to build, what sometimes required human intervention to make better predictions. While the deep learning models are difficult to build and they will use complex multi-layer neural network. So here, normally in deep learning, no intervention is required. Sometimes in machine learning, it is required. Whenever we are talking about feature engineering, so feature engineering in machine learning is done explicitly by the humans. But in case of deep learning, no need of feature engineering. Whenever we are talking about the goal, so the goal of machine learning is to give the output as close as it is to the expected output, because we know the input and output. So we have to give close to the expected output. But in case of deep learning, we have to continuously refine the output, so that we can get the best possible output that is very close to the best possible output. Whenever we are talking about the interpreting result, so it is easy to explain the result of ML model, but it is difficult to interpret the result of deep learning model, because it is dealing with the multi-layer neural network. So like if we are talking about machine learning algorithm, so mostly used algorithm in machine learning is SVM, support vector machine. So support vector machine having certain advantage and disadvantage. So the advantage of support vector machine is that it work relatively well when there is a clear margin of separation between the classes, as well as this is more effective in high dimensional spaces, as well as it is relatively memory efficient. But in spite of having many advantages, support vector machine is having certain disadvantages also, because as we know, this is the machine learning algorithm, so this algorithm is not suitable for large data set, and it does not perform well when the data size has noise. So if there is a noise or the size of the data is less, then support vector machine is not worked properly. So, and the deep learning algorithm that is used most widely is the CNN, convolution neural network. So convolution neural network are one most popular models that is normally used nowadays for the disease predictions, you can say. Because whenever we are talking about the medical data, so the medical data in every field, it is very large, whether we are going for brain tumor, prostate cancers, and other diseases, the size of data is very large. And even sometimes the data is structured, sometimes the data is unstructured. So the machine learning algorithms is working only for the structured data and for the thousand of rows only. If the size of data is large, so it is not working. So that's why nowadays in most of the medical imaging techniques, the deep learning models is working more accurately than in comparison to the machine learning algorithms. So CNN is the most popular deep learning algorithms that is used for this particular purpose. So what is happening? You can say this neural network computational model CNN uses a variation of multi-layer perceptrons as well as it is having certain advantage. Like if the size of data is large, there is no issue. If it is data is structured, unstructured, there is no issue. So very high accuracy in image recognition problem. So if we want to work in the image recognition problem, then CNN is giving very high accuracy. If the size of data is very large and even the data is structured or unstructured, then also this model is working very perfectly. Another advantage of CNN is it automatically detects the important feature without the human supervision. No human intervention, no human supervision is required to identify any features. This CNN model automatically detects the important features without any human intervention, as well as it is weight sharing. In spite of having like many advantages, the CNN algorithm is also having certain disadvantage. So one of the disadvantages is CNN do not encode the position and orientation of the object. So if we want to encode the position and orientation of the object, sometimes this model does not work perfectly. Another lack of ability to be spatially invariant to the input data. As here we do not have the output data, so sometimes it is very difficult to get close to the expected output. So a lot of training data is also required for this particular model because we do not have the output here. So the general flow chart that is used for this computer aided diagnosis of the disease, especially for the brain tumor. So first we have to do the data collections. So we have to collect the electronic data, omics data, and sensor data. We have to collect all three types of data. Then we have to do the pre-processing, image pre-processing. So for the pre-processing, we can do the filtering, we can do the masking also, and we can apply the certain filters so that the noise may be removed and the image is proper. After the image pre-processing, we have to do the segmentation. For the segmentation, we can use the histogram approach. We can use artificial neural network. We can use the age-based and region-based segmentation. We can use the k-means clustering. We can use the mean shift and fuzzy C-means. These are the certain algorithms that are used for the image segmentation. So according to the size of the data, we can select the algorithm for the image segmentation. After the segmentation, we have to extract the feature. So for the feature extractions also, we can select the algorithm as our requirement. The certain models that are used for the feature extraction are wavelet transform, textual features, and Gabor features. So after the feature extraction, we have to select the feature, like on what particular features we have to work, because we have not to work on all the features that are extracted. So we have to select the feature as per the like identification of the disease, which particular disease we are focusing. So for the feature selection, we are having certain algorithm like sequential backward selection (SPS), genetic algorithm (GA), and particle swarm optimization (PSO), and sequential forward selection. These are the certain techniques, algorithms that are used for the feature selection. So we have to select the features. After the feature selection, somehow, sometimes what happens like we have selected large amount of features. So we have to reduce the feature. After the feature selection, we will do the feature reduction. So for the feature reduction, we are using the ICA and PCA mostly. ICA is the independent component analysis and PCA is the principal component analysis. These are the two techniques that are basically used for the feature reductions. Sometimes kernel PCA is also used. So we will reduce the feature as per the requirement. Once the feature are reduced to the maximum possible level, then we are doing the classification. So for classifications, we are using the algorithms like SPM, ANN, SOM, fuzzy, PNN, MRF, RF, and CNN. First, before end, all the algorithms are for machine learning, but if the size of data is large and data is unstructured, then we can go for the CNN. So after the classification, we have to do the performance evaluation. So performance evaluation is done on certain parameter, like we have to check the sensitivity, we have to check the specificity and accuracy. Based on these parameters, we will do the performance evaluation, and after that, with the help of expert radiologist, we can diagnose the disease, like what is the level of disease in a particular moment. So whenever we are talking about the tumor grading, brain tumor grading, so as we have discussed, that brain tumor is of two types, benign and malignant. And as we have discussed, that benign is non-cancerous, they are having the clear boundary, they are not growing like very fast, so we have to not bother about the brain tumors. But malignant is the cancerous, their borders is also not limited and they are growing very fast. So we have to focus on malignant only. Malignant is of two types, primary and secondary. So in primary, there are three types of brain tumors, meningioma, glioma, and pituitary. So here the research is primarily focusing on the gliomas. So in glioma, it falls into the three category, level 1 or grade 1, grade 2, grade 3, grade 4. So if it is in grade 1 and grade 2, then it is low grade glioma. But if it is in grade 3 and grade 4, then it is high grade glioma. So we have to identify that whether it is in grade 1, grade 2, grade 3 or grade 4. Once we are able to identify the grade, then we can decide whether it is low grade or high grade glioma. So what is happening? So we are collecting the data and we are applying the algorithm depending on the size of the data. If the size of data is small, then we can go for machine learning algorithm. And if the size of data is large, we can go for this deep learning algorithms. So these MRI data is applied on the algorithms, and we are doing this, you can say, the segmentation, feature extraction, feature selection, feature reduction, classification, and we are able to identify the grade. Some of the public data set of the MRI that can be used for your research, you can use these data set for your research. These are freely available data set for the machine learning on the MRI data sets. So you can note down these data set. These are freely available. So if you want to focus research in on MRI data set, you can use these data. Some of the challenges is when we are focusing on the grading of this brain tumor. So first one is difficulty of brain tumor segmentation. As we have discussed, that it vary in the shape, size, and location. So it is very difficult to do the segmentation of brain tumor. Another, like difficulties of getting prognosis information. As we see that molecular information is shown to be expressed in MR image. So it is like whenever we are going through the MR image, it is very difficult to get the proper information. Another is the computational cost. As we have seen that we have to train the all amount of data related to that particular. So sometimes, like whenever we are performing this on the most complex model, so sometimes the computational cost is increased is on higher side. So these are the certain challenges when you are able doing the grading of brain tumor. So what is the significance of this study? If we are able to identify whether the brain tumor is benign type or malignant type. If it is benign type, then we have to not bother about. We have to take the normal treatment. But if it is malignant type and still in grade 1 and grade 2, then also we have to not bothered about, we can take the corrective action and we can recognize. But if it is in grade 3 and 4, then we have to like go for surgery, chemotherapy and other options available as per the suggestion of the medical practitioner. So this is the significance of study, that we have, if we the patient will know the exact picture, then he can decide the next course of actions, what is required to recover from that particular problem. So motivation, what is the motivation? So you can say the basic motivation is that, nowadays you are saying that, as I have told, that 250,000 persons are annually suffering from this disease, and the death rate is increasing. So if we are able to identify the disease at early stage, then we can reduce the death rate. So that's why these are the basic motivation, that being the human being, like if we can do something for the society. So if we are able to identify the disease, if we can build certain model and we can give to the medical practitioner, they can use that particular model for the early identification. And the basic objective of this research is like to extract the meaningful and accurate information from the MRI images and do like image pre-processing, segmentation, and other approach, so that we can identify the disease and we can grade whether it is in low grade or high grade. So these are the flow we have already discussed. That first we will take MRI data set as a input. After taking the MRI data set as an input, we will do the pre-processing, we will do the segmentation, classification, and after that we can decide whether it is lie into low grade or it is lie into high grade. So this is the block diagram of proposed methodology. First, we will train our CNN algorithm or SBM algorithm depending on the size of data. First, we will train our algorithm on the low-grade glioma and high-grade glioma data sets, so that the model will learn when it is high grade, when it is low grade. Then we will take the image, we will do the pre-processing, segmentation, and then we will apply the concept and we will get the exact output. So these are like certain research already done in brain tumor classification. So if you see that first one is used custom CNN model and their performance and accuracy is 97.1. So if you see like most of the time, first one they have used CNN, second one they have used AlexNet, fourth one is also used CNN, fifth one is also used CNN, seventh one also used CNN, eighth one, ninth one. So if you see like most of the like researchers, they are focusing on the CNN because the size of data here is very large, as well as the size of data is unstructured also. So that's why the CNN is giving more accurate result in comparison to the other result. So these are the if you see the research from 2015 to 21. So if you see that the CNN graph is very high in comparison to the other. So CNN is giving the better result in the grading of glioma into low grade and high grade. So if any question from that you can ask, otherwise we are moving to the next problem, that is using of MRI images in identification of prostate cancer. So if any question from previous algorithm, you can ask. So next one is another medical problem is prostate cancer. If we are talking about the cancer mortality in men, so most of the some man has admitted. Please mute yourself. So prostate cancer, you can say the primary cause of cancer. Do you want to say something? So like prostate cancer, most of the men's, they are like, So by the prostate cancers, like you can say, it is basically in men's only. And if you see the death rate in the prostate cancer, it is increasing day by day. So why we if we are able to identify the prostate cancer at early stage, then we can reduce the death rate of men. So multi-parametric magnetic resonance image (MPMRI) has become most popular in the identification of prostate cancer because here the MRI image is multi-parametric. So if we are using the multi-parametric
Sir,
MRI
sorry to
image,
interrupt, sir. Can you hear me, sir?
yes, yes,
I have one question, sir.
yes, yes.
Sir, after segmentation of brain tumor, we will be calculating the size of tumor, no, sir?
After,
Calculating after segmenting the brain
yes,
part we are extracting.
yes,
After that, we will be calculating the size of tumor, no, sir?
yes, yes, we are classifying.
Yes, sir. For this calculating the size of the tumor, whether we have to go for diameter or area or volume of the tumor, sir, because in some research papers they have given diameter, and in some research papers they have calculated area, and in some research papers they have given volume. So which one we can follow, sir?
This basically depend on the size of the data and whether it is data is structured or unstructured. Normally for the unstructured data, we are going for the volume.
Okay. Yes, sir. So the categorization of this glioma is also based upon the size of the tumor only, no,
Yes,
sir?
yes.
After extraction.
Yes, size of the tumor, whether it is increasing rapidly, whether we are able to identify the borders or not. If we are able to identify the border or not, that is all the parameters is used for the identification of it.
Okay, sir. Sir, in your research, whether you have used the ground truth image, sir, for
Yes, yes.
any.
I have used the data of AIMS Delhi also. We have used standard data set available freely that I have already shown. Apart from that, to get actual feel of the system, I have collected certain data from AIMS Delhi, and we have tried to find out the real picture.
Okay, sir. Is it necessary to use the ground truth image, sir? Because the data has to be get from hospitals, no, sir.
No, no. For the research purpose, for publication of research paper, it is not required to use the real data. But if
Okay.
you really want to develop a model, if you, I have filed the patent on this. So if that
Okay.
patent is granted, then we can do the commercialization. So if we are
Okay.
doing the patenting, then it is required to go for the real data.
Okay, sir. Thank you, sir. Thank you.
Anyone else wants to ask any question? So we are discussing about the use of MPMRI image in the prostate cancer. So some of the application of MPMRI images, like we can say it helps in the identification of prostate cancer. It also helps in delimitation of prostate cancer, and it is able to we can decide the menace of the prostate cancer, and even we can grade the prostate cancer. After the grading of prostate cancer, we can guide whether the biopsy is required or prompt assessment is required. So that is possible with these MPMRI images. So what is basic difference between MPMRI and MRI image? So as we have discussed, that MRI image is the normal image, and that MRI you can say it is a magnetic resonance image. But whenever we are talking about the MPMRI means multi-parametric. Here, the parameter we are having multi-parameter, so that's why it is called MPMRI, multi-parametric MRI image. Whenever we are talking about the lesson grading in prostate cancer, so it is also fall in the 5 category. So if the lesson grading of prostate cancer is in category 1, then we can say cancer is quite unlikely. Means it is very rare chance, very low chance that the prostate cancer is cancerous. Prostate is cancerous. If it is lie in the category 2, then we can say there is a chance that prostate is cancerous, but it is quite low. But if it is in 3 and above than 3, then we can say we have to like immediate attention, immediate health support is required. So from category 3 onwards, we have to bother, we have to take the immediate actions. So, and category 4, you can, if it reaches in category 4 and 5, we can say like we normally after the category 3, it is said that we are that particular person is in last stage. So beyond the category 3, it is like very dangerous. So before the category 3, if we are able to identify, then we can take the suitable actions. So whenever, as we have already discussed, that group 1 normal prostate cells will appear and the cancer will grow very slowly. But when it reaches to the level 2 or group 2, we can say most cells look like normal and the expected growth of cancer is very slow. But from the level 3 or group 3 onwards, normally we can say the size is normal, but the cancer is growing moderately, means it is increasing up to a certain extent. And after the category 4 or group 4, we can say cancer is growing very fast. So we have to identify the gradient. So machine learning algorithms are used, or the deep learning algorithm you can say is used for this identification of prostate cancers. If the size of data is less, then we can go for the machine learning algorithms. And normally we are using the SVM. But if the size of data is large, then we are using the deep learning algorithms. So in the, you can say brain tumor, we have used simple CNN, convolution neural network. But here, in case of prostate cancers, we are using the DCNN, deep convolution neural networks, and K means clustering algorithms for the clustering to grouping the particular segment. So the like first whenever we are talking about the analysis identification, so first we have to take the MP-MRI image, we have to do the examination on that particular image, then we have to do the image segmentation, and the image segmentation is done with the region of interest, like which particular region we want to focus. And for this image segmentation, we can use the deep convolution neural network, DCNN, K means clustering algorithms. And after that, we have to do the image pre-processing, feature extraction like the previously we have done, and then feature selection, and then we will train and test, and finally we validate the data. So, like whenever we are talking about the like deep learning approach, as we have discussed, normally here the data is very large, because if you see the data currently in the prostate, so most of the persons after the 50 years, they are suffering from the prostate. Even as per the study, is you can say more than 70% persons are having the prostate, but that is not necessarily that they are the cancerous. They may be in level 1 or level 2. So that's why here the data is very large whenever we are talking about the prostate. So that's why we are using the deep learning approach in the this identification of prostate cancers. So as we have already discussed that here the major focus is on the classification of lesson. So classification of lesson, we have already discussed that it is into 5 category. So depending on the methodology, we can decide whether it is in category 2, 3 or 4. Sometimes the problem arise, like as we have discussed that these prostate cancer lessons, they are also vary in shape, size and intensity. So if the shape and size is different, then like we have to train lot amount of data. Like if we have taken all the data for any particular one shape and size, so we cannot like able to identify if the shape and size is different. So that's why we have to take the precaution that we have taken into consideration all the possible shape, size and intensity data, as well as like if we are doing like simply 2D on the 2D space. So sometimes if the 3D space lessons is there, then we are not able to identify. So in that particular case, we have to also perform, locate the lessons in the 3D space also, so that we can finally get the most possible result. So the clinical significance of this classification is that if we are able to identify that whether the prostate is cancerous, non-cancerous, whether it is in level 1, 2, 3, 4, 5, so that accordingly, like the medical practitioners can take the suitable action. So that's why this research is primarily focusing on this aspect, the identification of prostate lesions, whether it is cancerous or not, whether it is lying level 1 to 5, what is the level. So if you see normally in this prostate cancer identification, somehow the XAI concept is also useful, because as we have discussed that here the data is very large, and here the data vary in shape, size also, intensity also. Sometimes it may lie in 2D, sometimes it may lie in 3D. So that's why you can say, along with like as the AI is blooming day by day, and you have heard about this expand explainable AI, that is XAI, and that is basically like you can say XAI is already with the help of XAI we can improve the ability to diagnose any particular disease at very early stage. So the second pillar of XAI in healthcare is that it is giving the most transparency in comparison to the normal AI concept. Machine learning, deep learning, all are the AI concept only. And XAI, you can say the extended version, or it is having like more feature. Here the domain sense is also there. Here the consistency is also there. Generalizability is also there. Trust and performance in comparison to the normal AI is increased. So these are like certain pillars that is basically used in the XAI. So you can go for how the XAI is helpful whenever we are talking about the XAI. So XML and XDL is also there, because machine learning and deep learning are the subset of AI only. So if we are using the XAI, explainable AI, then we can also like we can say we can use the explainable machine learning and explainable deep learning also. So what is happening that if we are using the EML or EDL, so then with the help of this EML, EDML, here we the identification, the perception is increased, because here we are focusing in all the aspect, means we are focusing the volume, intensity, 2D, 3D, everything. And apart from that, we are also like incorporating the explanations or the clinical expertise. So like here we are also somehow the prior experience is also included. So sometimes we can say like it is giving the better result in comparison to the normal MLTM. So how do you decide like which algorithm is best? As we have seen that in machine learning we have supervised, unsupervised, and in the supervised we are having the classification and regression, but in unsupervised we are having the clustering. So whenever we, like we want to do the classification, when we have to do the regression, when we have to do the clustering, and what are the algorithms that are used for the classification, regression, and clustering. So in order to decide the algorithm, like some of the consideration that you can take into consideration that which algorithm to use. So there is no best method, or you can say one size fits all. Means we cannot say that always SVM is giving the better result, always CNN is giving the better result, always naive Bayes is giving the better result. ठीक है. So depending on the like size of data, depending whether data is structured, whether data is unstructured, the size of data is small, the size of data is large. So depending on all these parameters, we can decide the algorithm. So there is no best method, or you can say any method that is fits in all categories. Another is trial and error. Like whenever we are performing any like experiment, so it is generally advised that perform that particular experience minimum 3 to 4 algorithms. You can perform 2, 3 for classification, 2, 3 for regression, 2, 3 for clustering. Then only you are able to identify that on this particular data, which particular model is giving the best result. So trial and error, you have to try each and every the maximum possible methods. If you try, then only you are able to identify that for this particular data, for this particular problem, this method is where this algorithm is good. Third point is size and type of data. I have already discussed that if the size is large, then the algorithm is different. If size is less, algorithm is different. If type of data means structured data, we can use different approach. If unstructured data, we have to use a different approach. Another is the research questions and purpose, like on what is the objective, like what are the research questions, what are the research objective, what we want to do. So according to our requirement, according to our research requirement, we have to decide the algorithms. So it is not like you can say, we can say that each, most of the cases, this algorithm is working perfectly. Okay, so according to your research questions, according to your research objectives, you can decide that which particular algorithm is giving the better result. Another, like how will be the output used? Well, like if we see that we are giving the input and output, then this algorithm is better. If we are having only input, then this algorithm. That is also not practically possible. Depending on your research questions, you can decide the things. So these are the like approach generally used in order to decide which algorithms to be used for this ML and DL algorithms. So whenever we are talking about the key challenges of the healthcare data, so as we have like if you remember in the introduction time, I have given that in the healthcare sector, day by day the data is increasing very rapidly. If you take the example of brain tumor, if you take the example of prostate cancer, so every year the data is increasing, and in most of the time it varies in shape, size, intensity, and sometimes we are getting the data in 2D, sometimes we are getting the data into 3D. So the major challenge in healthcare sector is that as the data is coming in all the shapes, all the size, the real world data sets is very messy, incomplete. So like if you want to, like as I have discussed, if you want to go for real research, if you want to go for the patenting, then apart from the standard data set, you have to perform the operations on the real world data set also. Like you have to collect the data from certain hospitals. And whenever we are talking, collecting the data sets from like certain hospitals, what is happening? The real world data set is very messy, and sometimes we can say incomplete also, because everyone do not know how to collect the data, and there is a standard parameters, and sometimes the data is coming in variety of format. If you go for AMS, they are giving the data into different format. If you go for certain local hospitals, they are giving the data into different format. So these are the major challenge. And whenever you are like pre-processing your data, so pre-processing, the prime focus is removing of noise and like making the image more perfect. So pre-processing like required like clinical knowledge and how to use the right tool. Which tool is basically used for the highest pre-processing. So that particular point has to be taken into consideration. So these are the certain challenges that you face whenever you are dealing with the healthcare data. So choosing the right model, choosing the right algorithm is also very necessary. We have already discussed in this previous slides. So the major challenge in healthcare is the data. Large amount of data varies in shape, size, intensity. Real world data is very messy. Then pre-processing algorithms, then selection of right algorithms. So challenges unique to medical imaging. Certain other challenges, like you can say compression algorithms. If the size of data is very large, then we have to use certain compression algorithms also. Whenever we are doing the compression, but when we perform the operation, then we have to decompress also. So whenever we are compressing and decompressing, whether it is lossy or lossless, that is also like one of the challenges. Another, medical image like always stored in lossless format. If any amount is like loss, if like during the compression and decompression, if any things is lost, then we are not able to accurately identify what particular disease is there. So that is the major challenge also. If the size of image is large, and like if you are asking data from, like if you mail to any particular doctor that please send the data, and he send the data into the compressed form, you if then you will do the decompress. If any loss is there, then how you can perform the right operation? That is like another big challenge. So recent research possible in medical imaging, like you can use magnetic resonance in MR image for targeted drug delivery. With the help of MRI images, you can do this targeted drug delivery. So you can also perform research in that particular direction. Apart from that, like blood flow simulation. Blood flow simulation is also like one of the research area. So if you want to do the computerized blood flow simulation with MRI scans, that is also like one of the recent research like you can do in this particular domain. Another is next generation contrast agent for use with MR images, and you can do the novel upper MR image modulatory, and you can also do in brain tumor, prostate cancer, and even you can do like some other recent problems also. So current trends in automation. So major advantage of doing all this medical imaging with the help of machine learning and deep learning, the major advantage, or you can say the major things is required is the automation. How we can do the automation with the help of computer assisted diagnosis, and accordingly how can be the treatment can be planned. So here the primarily focus, like if you are doing like on the liver, so how you can detect the tumor in the liver, how like what is the stage of this uh, tumor in liver, and what the treatment is required. So if you are able to identify, even in the breast cancers also same things is there. Like if you are having the samples, so you have to like do the pre-processing, segmentation, classification, feature extraction, feature selection, feature reduction, and finally suggesting like what is the stage of breast cancer, what is the stage of liver tumor, what is the stage of brain tumor, what is the stage of prostate cancer, lungs cancer. These all are the, but major focus is how accurately you are identifying and whether you are able to give the automation. So that is the major concept. And automation not only in the identification and grading, automation even if you are able to suggest the treatment, if you are suggest in the treatment planning. So that is the major, you can say, the current trend, current medical research is going on. So if any one of you want to do the research in the medical imaging, you can like take my help also. And one suggestion from my end, that you try to incorporate into your research like one of the medical practice, then you will definitely do like good research in that particular domain. Because without the intervention of any medical expert, sometimes what is happening, we are just performing the our like algorithms, and we are not getting the right approach how we can do the automation and how we can go for the patenting and also. So if you want to do the research in this medical imaging, whatever techniques you apply, whether you use data science, whether you use machine learning, deep learning, and even like MRI image, MP MRI image, but try to include like certain medical professionals also. Then you are able to do like good research in that particular domain. So these are like certain trends that you can use. So these are the you can go through. And so with the help of medical imaging, like you can help in the early identification of disease, and that will help the medical practitioner in the identification of the disease and suggestive treatment also, and they can take the quick actions so that sometimes whether like if you are able to identify whether the surgery is required or not required, whether it is only medication can be helped. So these are like certain benefits of this like research you can do. Apart from that, like whenever we are doing the research in the medical domain, So here you can say faster data acquisition is also required, and you can say the telemedicines and somehow the nowadays if like we have to secure the data also. So whenever we are talking about the medical data, so if we want to like, incorporate the security features also in that particular medical data, then we can also incorporate this blockchain concept into our medical imaging research. So this is all about how like you can start the research in the medical imaging. If any question you can ask. These are the certain segment still gaining momentum. Uh, so in like biomedical, very less research is done. So here a lot of focus is required. And the computer-aided biomedical imaging, if we are able to do, then this will definitely like very helpful for the medical field. And nano imaging is also like very much required, as we have discussed that the size of data is increasing day by day. So how like the big data concept can be used in the biomedical imaging, and how we can do the 3D visualization, virtual reality also. So these are the certain features. So, but in somehow like we have to focus on the certain aspect that we have discussed, that how we are collecting the data, how we are doing the pre-processing, how we are doing the segmentation, how we are doing the feature extraction selection. So basically all the output depending on the these parameters only. So that's why I am suggesting whenever you want to do the research in this particular domain, do not depend on any one algorithms. Whenever you go for the papers, you find most of the papers on the similar lines. They are using the standard data set, they are performing the operations, and simply they are calculating the amount. So that is not the right way of doing research in the medical, because here it is basically related to the life of a human being. So try to do some novel research in this particular domain, and that will be beneficial for the society. So thank you all. If any question you can ask.
Sir, I have one doubt, sir.
Yes, yes.
Uh, Sir, what is the scope of image fusion in cancer diagnosis, sir?
Your voice is not audible. Can you repeat it?
What is the scope of image fusion?
Image view.
Fusion
Yes.
in cancer diagnosis.
Image fusion is sometimes is used in the cancer identification. So what exactly is the question? How we can use?
Scope of image fusion in cancer diagnosis.
And that is used.
Yes, sir. Okay, sir.
Image fusion, it is not like you can say everywhere it can be used. Like if you are working for the prostate cancer, if you are working for the like lungs cancer, then it is not useful. But in some cancer, like if you want to perform the like intervention or cancer identification in the rectal cancer, then it is useful. So depending like on what particular field you are working.
I am working in brain tumor diagnosis, sir.
So brain tumor normally image fusion do not play like you can say very much role in that particular field.
Okay, sir. Thank you, sir.
So, is there any more question? Any participant? Okay. So, thank you so much, sir, for your insightful presentation during the short-term course, Zero to Advanced Machine Learning Techniques in Disease Prediction. Your lecture provided a deep dive into the application of machine learning in healthcare, focusing particularly on the detection and grading of brain tumors. You outlined the latest methodology and algorithms that are being employed to improve the accuracy and efficiency of tumor detection, a crucial aspect of oncological diagnostics. During your talk, you also addressed various challenges facing the field, including issues related to data accuracy, model reliability, and the ethical considerations of deploying AI in clinical settings. You discuss how these challenges can impact the effectiveness of machine learning models and explore potential solutions to overcome them, emphasizing the importance of robust data sets and transparent model training processes. Your session underscore the transformative potentials of machine learning in enhancing disease prediction and management, showcasing its ability to not only detect diseases at an early stage, but also to provide more detailed assessments for personalized treatment plans. We greatly appreciate the depth of knowledge and practical insights you share, which have enriched our understanding and spurred interest in the further integration of AI technology in medical diagnostics. Your contributions to our learning journey has been immensely valuable, motivating us to explore and implement these advanced technology in our future healthcare projects. Thank you again for a truly informative and inspiring session, sir. Your experience in advancing the applications of machine learning in healthcare is deeply valuable. Thank you so much, sir.
Thank you, Dr. Dilip, and hope it is like useful for the participant that they can learn how they can start the research in the medical imaging.
Yes, sir. Yes, sir. This is going to be very helpful as per our theme of short-term course. Of course, it is going to be so much valuable for this sort of course. So, okay, by tomorrow from same time, please.
Oh, okay, thank you. Thank you.
Thank you, sir. Thank you so much, sir. Please. We will meet. We have to follow the same schedule by tomorrow. And tomorrow is the last day. Please be joined. And well, lecture session is compulsory to everyone to get certificates. Okay. Thank you, everyone.